Today is July 18th. This is Bio 225 Microbiology. The lab that I'm doing today is going to be basically the results for bacterial enumeration dilution. So I'm going to put this right here. It's a lot, so I didn't have a little post-it to put near my slides. However, I'm going to leave this here so that I guess for copyright issues, everybody can see that it's mine. So when discussing this particular bacteria, I guess I'll start with what I had an issue with. When it comes to like making sure that the bacteria was growing right or done right, the description was really easy to follow. However, I think that the pipette made it pretty difficult to get an accurate growth when it comes to like colony counting. So when we think about like the colony counting and getting an accurate result anywhere from 30 to 300, I think that my best result would probably be TSA 10 to the 5th power, so diluted. If you can see a little bit, there are numerous colonies. However, there's larger ones and then smaller ones. I hope that you can see the smaller ones, so then it gives a better understanding of exactly how many colonies are in there. So this is going to be dilution basically number 5. When I'm looking at the overall result from my experiment, they're kind of inconsistent. In the end, I will show a better, I guess, close-up as to my results, but just to give you a quick understanding, this is going to be my result for number 1, which wasn't really diluted, and there isn't many colonies. It does have this shadow appearance, which I think implies that there's multiple colonies. However, there's not really a way to say that is exactly, that they're really colonies. For another example would be 10 to the 4th power. This one, it does have a lot more colonies, and you can see like the very deep indentations of each one that would kind of present, this is far more than 300. So obviously this is not an accurate result that we could count. However, I did want to just provide those examples because it shows that from 1 to 4, the dilution is odd almost, and again, inconsistent. So I think that with that being said, that the reason is really because of the pipette. I think that maybe I didn't properly dilute it, which I will work on in the future. I think that's something that I'm also going to be able to do that will help me in future experiments, is that I'm going to be gathering some sterile TB syringes from work, which I can utilize in these experiments that will give me a little bit of a better accuracy when it comes to dilution and counting the colonies. So I think overall the experiment went really well. I didn't think that it was going to be easy by any means. However, I do think that I am happy with the result. So when it comes to this particular bacteria, this bacteria is used in real life through fermentation. People use it in wineries, distilleries, to help to ferment the sugars that are presented, whether it's in fruit for wine or the wheats for beer, or I think it's also, I'm sorry, it produces ethanol also in hard alcohol. So when we think about this bacteria, the yeast, it produces, like I said, it produces ethanol. It also combines with the carbon monoxide, or the carbon dioxide, excuse me, so that it floats to the surface. So that way that these yeast products or this bacteria can be collected and used for other different types of fermentation. Well, not different types, but can be utilized so that they can get that same fermenting experience, whether it be the aroma or the just the way that it ferments. They gather that yeast from the top of that fermentation so that they can get that same taste in another batch. So for example, at wineries, this particular bacteria can create some really unique aromas that might not be able to be remastered if it was that they didn't utilize that same exact fermenting bacteria. Since there are other strains, not all are produced and can equal, I guess, that same flavor as to that particular one that they can recollect. So for me, I like wine, and so that's a I guess something that can be utilized or thought about in real life situation when going to a winery, is kind of how this bacteria plays a really important role in how we get our wines. So I hope that is everything. Again, I really enjoyed this experiment, and I hope that the ones in the future are just as well put together and kind of formulate similar, because I do feel like I got a decent result. So I'll go ahead and show you the up close so you can see. Let's turn this around if I can. Oh, I cannot turn this around. So we can go over slide number 1, or plate number 1. This is going to be plate number 2. This is going to be plate number 3. Sorry, I'm trying not to get a glare in there. Again, this is plate number 4, and you can, excuse me, you can kind of see all of those little colonies. I'm trying to get not a glare. There you go. You can see all of these little colonies, which kind of shows that inconsistency that I was talking about. So this would be plate number 5. This is my chosen plate. If I was able to get a better close-up, I think that you can see around the ridge there are numerous colonies that are formulated that are over 30 but yet under 300, that will allow me to say that that is an accurate plate. And then last but not least, this is number 6. This also has in between 30 and 300. However, it does have along the ridge line, I hope that you can see, along the ridge line there are numerous little tiny colonies, and so I couldn't say that that was accurately between 300. Again, I hope that this is correct, and moving forward, if there's anything else that I need to present, please let me know. Thank you so much. Bye-bye.